Hi everyone, our presentation will cover on eigenvalues and eigenvectors of matrix algebra. What is eigenvalues and what is eigenvectors? So let's take a look. Eigenvalues and eigenvectors given by the formula Ax equal to lambda x, where A is any matrix, x is eigenvector, lambda is eigenvalue. The eigenvalues also can be expressed in polynomial form, where f lambda equal to lambda identity minus a, or equivalently the n roots of the discrete polynomial equation, lambda identity minus a equal to 0. To improve our understanding, let's have a look on one example. Given that x equal to matrix 1, 2 is an eigenvector of matrix A, 2, 4, 0, 2, hence find the corresponding eigenvalue. By using the formula Ax equal to lambda x, first of all we have to substitute the value of A and x, and then we got 5/2. The 5/2 we get here actually the value of lambda x. We do the comparison by making sure here is the value of x, and we got lambda is equal to 5. Therefore, the corresponding eigenvalues is 5.
Okay, hello. Now I am going to explain the example to determine the eigenvalues and eigenvector of the 2 times 2 matrices. The question asking to determine the eigenvalues and eigenvector for the matrix B. Given that matrix B is 1, 2, 3, 2. The first step we need to do is to let B as 1, 2, 3, 2. Then the eigenvalues lambda of the matrix B satisfy the characteristics equation. Equation given that B minus lambda identity is equal to 0. First, we need to just insert the matrix B and the matrix identity in the equation. So it should be like this. After that, we will just proceed it by multiplying the lambda. So we will get the 1 minus lambda, 2, 3, and 2 minus lambda equal to 0. By using determinant AD minus BC, we will get for the equation. First, multiply A and D, that is 1 minus lambda multiply with 2 minus lambda. Then minus with B multiply with C, that is 2 multiply with 3. Then we will get lambda square minus 3 lambda minus 4 equal to 0. After that, we will just factorize it to get the root. Finally, we will get the value of the lambda, that is -1 and 4. Hence, the eigenvalues of matrix B are lambda equal to -1 and 4. Okay, settle with eigenvalues. Now we will identify the eigenvectors of the matrix B. We are going to make the solution of it one by one since it has two values of eigenvalues. That is -1 and 4. The first lambda, when lambda equal to -1, based on equation Ax equal to lambda x, we should have 1, 2, 3, 2 times with x1, x2 equal to -x1, x2. If we multiply and arrange it, we will get the 2x1 plus 2x2 equal 0, or 3x1 plus 3x2 equal to 0. Therefore, when 2x1 plus 2x2 is equal to 0, so x2 is equal to -x. If x1 equal to k, where k is a constant, so x2 is equal to -k. Then from equations, x is equal to k, -k. Then when we move that k out, it will get 1 and -1. So the eigenvector when lambda equal to -1 is 1 -1. Okay, settle for lambda equal to -1. Now we will move to lambda equal to 4. We have 1, 2, 3, 2 times with x1, x2 equal to 4 times with x1, x2. Same with before, we should get -3x1 plus 2x2 equal to 0 or 3x1 minus 2x2 equal to 0. Since -3x1 minus 2x2 is equal to 0, so x2 is equal to 3 over 2 x1. Let x1 is equal to 2k, so x2 is equal to 3k. Then, based on equation, x is equal to 2k, 3k. And then, when we move out the k, we will get the eigenvector when lambda is equal to 4, that is 2 and 3. Okay, I think that's all from me. We will move to the next presenter. Thank you.
Let's write another example. Determine the eigenvalues and eigenvectors for this matrix. A 1, 0, 0, 3, -2, 0, 2, 3, 4. First of all, we need to find the eigenvalues of this matrix. To find the eigenvalues, we need to use this equation: A minus lambda I multiplied by eigenvectors. From this equation, we can find a new matrix, which is 1 minus lambda, 0, 0, 3, -2 minus lambda, 0, 2, 3, 4 minus lambda. From this new matrix, we can find the determinant of this matrix. Using the determinant formula, we can find the determinant. So we need to find the determinant. We get this new equation, which is 1 minus lambda negative multiplied by -2 minus lambda multiply 4 minus lambda. As you can see here, we can get the value of the lambda from this equation. We can get the value of lambda, which is lambda equals to 1, lambda equals to -2, and lambda equals to 4. Next, after we find the eigenvalues, we can find the eigenvectors. First of all, to find the eigenvectors, we need to find the value of the eigenvectors. Each of the eigenvalues that we get before this. Okay, first we try to find the eigenvectors for the lambda 1. To find the eigenvectors, we need to use this equation, which is A minus lambda I close bracket multiply by eigenvectors equal to 0. After that, we just replace the value lambda with 1 and we solve the matrix equation, and we got this new matrix, which is 0, 0, 0, 3, -3, 0, 2, and 3, 3. Okay, because of the first row is 0, 0, 0, so we didn't need to use the elementary row operation to solve this problem. So because of the first row is not gonna give us an information, we just go to the second row, which is 3, -3, and 0, which using this equation A minus lambda I multiplied by eigenvectors equal to 0, we can get this equation. We can get this information, which is 3x1 minus 3x2 equal to 0. So we can find the value for x1 and x2. So after we simplify this equation, we get the result for x1 equal to x2 and equal to 1. So after that, we try to find the value for the x3. So according to the third row, 2x1 plus 3x2 plus 3x3 equal to 0. As we know, we already find the value of x1 and x2, so we just replace the value and we got the equation 2 plus 3 plus 3x3 equal to 0. So we just simplify this equation and we got the value of x3, which is -5/3. So we can get the eigenvectors, which is x1, x2 and x3. The value of x1 is 1, the value of x2 is 1, and the value of x3 is -5/3. So this is the eigenvector corresponding for the lambda 1. So next, we need to find the eigenvectors corresponding for this lambda -2. What we're gonna do is the same process, which is we replace the value of lambda with -2 and we solve the matrix and we got the new matrix, which is 3 0 0 3 0 0 2 3 and 6. Using this matrix, we can find the eigenvectors of the lambda equals to -2, which is we can see as the first row. We can find the value of x1, which is 3x1 equal to 0 and x1 equal to 0. For the x2 and x3, we need to use the third row of this matrix, which is 2x1 plus 3x2 plus 6x3 equal to 0. Okay, after as we all know, the value of x1 is 0, so this can be gone. Okay, after that we just simplify the equation and we got this x2 equals to -2 x3. So in this case, we assume that the x3 is equal to k, which is a constant. So we replace the x3 with the k, so x2 equal to -2k. So after that, we replace the value from the s1, s2, and s3 into the eigenvectors. So for the eigenvectors for the -2, lambda equal to -2 is 0, -2k and k. So what we're gonna do is we throw out the k and we got this eigenvectors, which is k matrix 0, -2 and 1. So next, okay, after that we find the eigenvectors for the lambda equal to 4. We just use the same process. As you can see, we replace the value of lambda with 4 and put it into the matrix identity, and we can get a new matrix, which is -3 0 0 3 -6 0 2 3 and 0. After that, we find the value of x1 using the first row of the matrix, which is -3. So you can see the value of x1 is equal to 0. The value of x2 also equal to 0 using the second row of this matrix. Alright, according to the third row of this matrix, we can get this equation 2x1 plus 3x2, which is no x3. We cannot find the value of the x3, so we assume that the x3 is a free variable and we put it as 1. So the eigenvectors of this eigenvalues, which is lambda equal to 4, is 0, 0, and 1. Okay. Thank you for your attention.